Hello. Welcome to United Astronomy Clubs of New Jersey. We are here once again in Jenny Jump State Forest in Hope, New Jersey. Since it's 8 o'clock and a lot of people like to not realize that presentation starts at 8, not get here at 8, just going to give them a couple minutes to maybe get up here, find seats, park safely without running people over. I do want to welcome not only everyone who is joining us here in the park, but also online, because that is right, we do live stream these on Twitch and YouTube. So if you're ever wondering what to do on a rainy Saturday night like today, and you're not brave enough or camping and want to learn neat and cool, interesting stuff and don't want to come out to the state forest, feel free to join us online. We do have links to those on our website. Speaking of our website, uacnj.org. You're going to find those links, like I said. You're also going to find a list of all our upcoming and past talks so that you can know what we're up to next, as well as information on our member clubs. Because that's right, we are actually a club made up of all sorts of different clubs in the area. And one of the easiest ways to get into really any hobby, but especially astronomy, is to find and join your local club. They're going to have all sorts of fun, interesting information, ease of access, but also chances are they're going to have tips and tricks that might be more relevant to you because the ones I know for out here in Warren County, New Jersey, oddly enough, don't work as well if you live in places like Dan. Out in West Orange.
Yes, tell the entire internet where I live.
West Orange is not necessarily a small amount of people.
That's true.
Newark is not a small amount of people. Scranton,
Yeah.
not a small amount of people. I'm talking general areas. I'm like, I think it's that area.
So for those that don't realize, the joke she's making is that where I live has obscene levels of light pollution.
Also, much more people than I can handle. But besides that, you don't need to know that I basically grew up on a farm. He grew up around people. He is more friendly and socialized, apparently. Besides the point.
I grew up by a beach.
You can also find out what we're doing on our social media, our Facebook, Instagram. We have a Discord server. They're all great places to find out what we're up to, as well as share your own astronomy journeys or even ask questions. Like, hey, this piece fell off my telescope. Do you happen to know where it came from? Chances are there's someone who knows that piece, has had it fallen off, and can tell you how to fix it. If not, we might also know a good source to find those answers as well. Yes, online people, it is in fact light outside. The one of the problems with the yearly cycle and daylight savings time is it gets late a little darker. But so we're gonna get going here.
Dark a little later.
I don't know what came out of my mouth, but I'm just going to assume it was not correct. I'm going to give myself some grace because I have a migraine and I'm doing the best I can, Dan. With that, you're not here to listen to me blabber on, so I'll get right into the safety for those of us who are joining us here. Oh gosh, the heckling. Online people, I wish you could hear the heckling. So if anyone here needs to use the restroom, that is the porta potty in back. It is big, it is blue. When it finally does get darker, it is illuminated by a red light for ease of finding in the dark. We also have a little museum and gift shop area through the doorway surrounded by the red rope light. Feel free to go check that out. It houses our meteorite display, as well as some other fun tidbits. When you were coming in, you might have noticed all the sheds out there. Each of those sheds has a roll-off roof and houses its own telescope. On a day where we're not much more weather inclement than usual, we would have one of those open so we can go see stargaze after. Oddly enough, since it is kind of raining on and off still, we were hoping it was going to get clear earlier. We would have the roof rolled off and a volunteer manning that
telescope.
One of the telescopes in one of those sheds.
Each of the telescopes in the open sheds.
Yes. Anyhow, it does get dark in the state park, so we do ask that when you go to leave, you do use your headlights, just because it kind of is less than ideal when you get run over. No one needs those hospital bills. Let's avoid that. In addition, despite what I said, about it getting dark, we do have a full moon coming up on Tuesday, something like that.
So the moon should be visible tonight if the clouds break.
So,
which they might.
You should be fairly good wandering around, but if you happen to need light or whatnot to watch where you're going, watch where you're stepping, we do ask you keep those, like, any flashlights or cell phone lights pointed towards the ground. That way we don't blind anyone with the latest, greatest 100,000 lumen monstrosity from Amazon. That is, in fact, no fun. So, with that, We're going to get into tonight's program about the Fermi paradox with Daniel Kirby. Dan has a bachelor's degree in physics with a minor in history and a master's degree in computer science. He has been
Amateur.
an amateur astronomer since childhood and is a member of the board of the Amateur Astronomers Association of New York, AAA, not to be confused with the
the other
side
guy, the other
service,
AAA guys.
and the board of United Astronomy Clubs of New Jersey. He is also the site coordinator for AAA's activities here at Jenny Jump Observatory. He has spent many a lonely night, and don't let him fool you. By lonely, he means full of other friends also doing astrophotography up here at Jenny Jump, wandering between the stars. And while astronomy is by far Daniel's most passionate hobby, he enjoys reading, cycling, camping, and riding one-wheel.
Self-balancing personal electric vehicles.
It's a one-wheel.
Yeah, a self-balancing personal electric vehicle.
For his day job, Daniel is a software engineer, and you can follow his astronomy on his Instagram, which he will shamelessly plug after he's done heckling me. With that, here's Dan.
The true heckling has to come from inside. But yeah, okay, so the title of the talk is Let's Solve the Fermi Paradox. So to do that, we have to figure out what the Fermi Paradox is. But first, we're going to do a little experiment. So, who here believes that extraterrestrial life exists? So this is our galaxy, the Milky Way. It contains about 100 billion stars and likely about as many planets. We estimate there are about 300 million habitable planets in the Milky Way, and that is based on the SETI Institute's definition of habitable, which means that it's in the habitable zone of its star, meaning that liquid water can exist on its surface. So, given that information, who here thinks that there is extraterrestrial life in the universe? All right. Who thinks, what the heck just happened? Keep your hand up if you think there's extraterrestrial life within our galaxy. So that would be about 100,000 light years away. Okay. What about within 100 light years, which is actually smaller? But yeah, this is a 300 light year radius. So that's a lot more than that. Okay. So hands are starting to go down now. Keep your hands up if you think there are extraterrestrials within our own solar system. What about on Earth? What about here at the observatory? All right, so, okay, so that gives an idea of where we are. So I'm going to issue a spoiler warning. If you're like me and you have a big stack of science fiction novels about meeting extraterrestrials on your TBR at home, I'm going to wind up spoiling a couple of them. I've been kind of careful not to be too spoilery here, but basically what we're going to do tonight is I'm going to explain what the Fermi paradox is and how it relates to the problem of extraterrestrial life. Then we're going to go through a list of 8 potential solutions to the Fermi paradox. Solutions that suggest that we are alone in the universe. Solutions that suggest we are not alone in the universe, 4 of each. And then we're going to do a March Madness bracket, and we're going to choose one solution that is the favorite of the group for the evening. So first, I need to explain what the Fermi paradox is. So the Fermi paradox was articulated by Enrico Fermi in 1950. So Enrico Fermi was an Italian-American physicist. He worked on the atomic bomb, and he was really famous for this class of scientific problems called Fermi problems. So he would often, the story goes that one day one of the guys who was working for him hit a coyote with his car on the way into the lab where they did the Manhattan Project. Yes, Oak Ridge. And so he was like, if we figured out how many automobiles are registered in the state, and how many miles of road there are, and how many coyote collisions there are every year, we could figure out how many coyotes there are in the woods, right? So this is kind of a similar idea. At the time, another little anecdote, there was this, for some reason, there was a bunch of trash bins that were going missing in New York City. at this time. And so there was this comic strip came out where these aliens come down and they land and they bring back all the, for whatever reason, they were abducting the trash bins and they're bringing them back. So there was one of the guys at the lab saw this comic and said, like, where is everybody? Why have we not encountered um extraterrestrial life? Or actually, Fermi was the one that said that. So that's the lunch conversation. I'm sure that if you majored in physics in college, you probably had lots of lunch conversations like this. I know I did. But basically, we extrapolate from this kind of offhand conversation to this sort of classical form of the Fermi paradox, which is basically that our universe is very large. It is much older than we are. And if it's possible to engage in interstellar travel, manned interstellar travel, then you could colonize the entire galaxy in only a few million years, which is a short period of time compared to the age of the universe. So therefore, where is everybody? Why have we not encountered extraterrestrials in person here on Earth? Now, there's a related idea that appears a little bit later called the Dyson dilemma. So Freeman Dyson was another physicist, and in 1960 he made this observation that our civilization has historically demanded an ever increasing quantity of energy. And basically, we actually see that the only times that energy consumption drops in an aggregate form are like calamitous events, like COVID-19, right? Like where, a lot of people stop driving, they stay home, so now we're using less gas, we're using less energy. And so if you extrapolate forward, it seems that civilization will eventually need all of the energy that the sun puts out, and the hypothetical device to harvest that energy is called a Dyson sphere. So this idea that, so basically what Dyson was suggesting is that we should look for evidence of megastructures. We should look, if we want to find aliens, we should see, well, if you had taken a star and you had ziplocked it for freshness and you were taking all of that solar energy and using it to power your TikTok algorithm, then you would inevitably wind up leaking infrared radiation because there'd be like waste heat in your processes. So basically, he's proposing the idea that somewhere out there in the universe, you're going to find this infrared star, and that would be a Dyson sphere. And so far, we have not seen stars winking out of existence as their inhabitants, Dyson them up. We see them winking out because of light pollution, but that's a whole other problem. And then there's a third idea that I want to introduce here, which is the Great Silence. So the Great Silence, basically, Fermi is talking about direct physical contact with extraterrestrial civilizations. At the time that Fermi is making these comments, right? This is basically the infancy of radio astronomy. So we don't really have anybody looking at other stars yet and saying, "Hey, is there any radio signals coming in?" That starts around the early 1960s. Dyson's talking about basically Kardashev type 2 civilizations being observed remotely. Oh, what's a Kardashev type 2 civilization? I'm going to get into that too. The Great Silence, it refers to the fact that we observed a few decades later that we don't see any signs of extraterrestrial communication. So we never found any repeatable anomalous signals from outer space. Notice I put an asterisk on the word repeatable. So this is the source of the asterisk. This is the WOW signal. It's also my license plate number. So on August 15th in 1977, there was this radio telescope in Ohio State University called the Big Ear. It was built basically to survey the hydrogen sky. So it basically it operates on the hydrogen frequency, and it rotates with the Earth. So it's basically taking like this long-term survey. It was used basically to map the sky in hydrogen. And when it was finished, Frank Drake suggested, hey, we could use this for a SETI mission. We could use this to look for extraterrestrials who might be signaling on this frequency, because this frequency happens to be kind of quiet and also is a frequency that most civilizations would know is interesting because they know about hydrogen. They know that it's like the atomic frequency that hydrogen emits. And they gave this like postdoc, or I guess he was maybe a grad student, the task of like reading out the magnitude of the signal that the telescope produced, and he found, and it was represented like 1, 2, 3, 4, 5, 6, 7, 8, 9, and at 10 it switched to A, and then B, C, D, and so he saw this 6EQUJ5 and circled it and wrote "wow" because it was, that high, like that high out of the normal. So this. Now we've done a bunch of surveys to try to recapture this signal. We've never seen it again, never seen it repeat. We've also had some other candidate signals that have been interesting, and none of those have repeated either. The WoW signal, I would say, is actually basically the most interesting, like, it could be aliens thing that we've ever seen. I think there are convincing non-extraterrestrial explanations now, but it kind of took 50 years for a paper to come out that I would say was more believable than it was some sort of artificial signal, even a reflected, human-made signal. Okay, so I mentioned the Kardashev scale before. I'm going to reintroduce that now, and maybe this can make sense of sort of our picture of what it would mean to be an alien civilization. So there was a Russian astronomer who proposed this. His name was Kardashev, obviously, and he defined a Type 1 civilization as a civilization that consumes 100% of the energy output of its home planet. So we're at about Type 0.7 right now. We're actually using a lot of the Earth's energy. Type 2 would be a civilization that commands 100% of the energy output of its star. And Type 3 would be a civilization that is able to command 100% of the energy output of its galaxy. So basically, Type 2 is when you build a Dyson sphere, and Type 3 is when you build 100 billion Dyson spheres. And to sum that all up, it appears when we look at the night sky and we look at the universe, we appear to be alone in three ways. We are not the province of some great galactic empire like in Dune, and we don't observe any up around the stars, so this would be a Type 3 civilization. We haven't found any alien artifacts or evidence of ancient aliens exploring our own solar system, like the monolith from 2001: A Space Odyssey, which would presumably be something like a Type 2 civilization that was doing interstellar travel. And we haven't found any radio signals from an extraterrestrial civilization like in the movie Contact, which would be possible with a Type 1 or lower civilization. We actually have the capacity now to signal to other, below Type 1 civilizations with our radio telescopes. If we knew where they were, and we knew where to point it, and they knew where to point it, and we were, trying to chat back and forth. So now one other thing I want to introduce is a few rules of thumb for considering the problem of extraterrestrial life. Three of these. So first, well, I guess these are two that kind of go at loggerheads to each other. So one of them is the Copernican principle, which was, as you might imagine, introduced by Nicholas Copernicus, which basically says that we should assume that our position in the universe in both time and space is not special. Basically, this is the assumption that we're always taking a random sample. A good way to think of this is like if you were taking the bus and you knew that the bus came every 10 minutes, and somebody asked you, like, you didn't check the clock, but somebody asked you, when do you think the bus is going to come? You would say about 5 minutes, right? Because you figure, like, on average, like, you're the average case. Now, on the other side of that coin, we must consider what is called the anthropic principle, which is basically this idea that the range of possible observations is restricted by the requirement that we exist to make the observation. What does that mean? Well, think about it in these terms. We can't live on Mars. It is not possible for human beings to live on Mars. Mars is not habitable. So we know why we're not on Mars. We know why there isn't life on Mars. So our position in the universe must be at least a little special, in the sense that like, if there are some constraints that prevent us from existing, then that would dictate, at what time and what place we exist. You'll see a few of the Fermi paradox solutions kind of touch on these conflicting ideas. Another rule of thumb I want to introduce is exclusivity. So if we want to have a universal solution that tells us why there aren't any aliens, it has to be exclusive. It can't be something that is arbitrary and appears for no reason. So in this example of exclusive sets, right, I'm giving the example of, say, civilizations that have discovered radio communication are a subset of civilizations with mathematics. You can't have a radio without mathematics, because you need to know what pi is to make a circle. Now, on the other hand, there are some people who will say things like, well, maybe the reason why we don't meet aliens is because they think we're boring. Like Earth is blah. Like they don't want to come here. Well, I got news for you. Ohio has a thriving tourism industry. Just because some place is boring or some topic seems boring to you doesn't mean that it's going to seem boring to everybody. So we would suggest that, like, it's possible that there's an overlap between civilizations that have the technology to contact us and the ones that think we're boring and don't want to talk to us, but it's like an arbitrary decision to say, oh, well, nobody wants to talk to us. So what's the difference here? The difference is that if we had some good reason to think that the discovering mathematics was extremely unlikely. It only happened here. We're the only people, the only civilization that's ever done it. Then that would make sense. But there's no good reason to think that being interested in Earth is a universal thing. And then finally, this is an expression that you will encounter in SETI astronomy in searching for extraterrestrials. We have the saying, it's not aliens until it's aliens. So basically what that's saying is that, extraterrestrial life is an extraordinary result. It's not something that a conclusion you want to leap to. Yes, we want to believe, we want to find aliens, and it's fine for astronomers to interrogate the question of alien life, to include it on the differential, but we expect evidence, and we want to rule out all of the more mundane alternatives before we conclude that we have found aliens. Another way to say this is, Carl Sagan's famous quote, extraordinary claims require extraordinary evidence, which, I'm sure you're aware, Carl Sagan didn't actually say. He said extraordinary claims require extraordinary proof, but this is one of those, like, misquotes that becomes more famous than the quote. It's like, beam me up, Scotty, or just the facts, ma'am. It's one of those ones where it's like, he never actually said it. But yeah, okay. So we're going to talk about some solutions where we are alone. These are the bummers. So one I'm going to introduce is called the Great Filter. This is our first one. So this was conceptualized by an economist named Robin Hanson in 1996, who is not an astronomer. And basically what he observed is that there was a series of difficult milestones that had to be passed in order for industrial civilization to appear on Earth. Remember that thing about inventing mathematics? And it's possible that one of these milestones is vanishingly unlikely. Or, more worrying, there might be a future impassable milestone that we have not yet met, right? So some potential great filters in our past, the emergence of life on Earth, the transition from prokaryotic to eukaryotic cells. So this is called eukaryosis. Basically, like, a prokaryotic cell is like a simple single-celled organism, and a eukaryotic cell has like little organelles inside it. And what we think probably happened is that at one point Earth was covered with prokaryotes, and one day one prokaryote ate another prokaryote, and the one on the inside turned into the mitochondria, which the real ones know is the powerhouse of the cell. Not sure whether that reference still scans. That's very much a millennial reference. But yeah, so it's from Mean Girls. Now, the transition to multicellular life, that was recently replicated in a laboratory experiment, so it's probably not that one. The emergence of intelligent life, I could go on. There's a whole bunch of these. Inventing taxes. Now, some potential great filters that could exist in our future. Nuclear war. Climate change, artificial intelligence. Oh man, this every year I give this talk, that one gets a little spookier. Pandemic illnesses, which I anticipate some people might be saying, "Whoa, Dan, but we've always had pandemic illnesses. Those aren't new." Actually, they are new. Pandemics, like in our conventional understanding of them, require like intercontinental travel. Like we had epidemics before the 20th century. Now we get pandemics where they go all over the world. And then there could be some other unknown technological hazards that we just don't know about, right? Like if we were making this list 100 years ago, nuclear war and artificial intelligence would not have appeared on it. But yeah, so wait a minute. You're thinking, but wait, how does this solve the Fermi paradox? Why is this a resolution? Well, basically, it doesn't actually matter whether the filter is behind us or ahead of us. If it's behind us, that would mean that we're sort of the firstborn, right? Like if we pass the filter, basically nobody else gets through the filter, so we're ahead of everybody else in our region of the galaxy, in our galaxy, possibly in a bunch of local galaxies, or it's ahead of us and that would suggest that this our galaxy is filled with civilizations like our own, and they're all doomed to fall to the Great Filter in the near future. Um, yeah, is that a nice bummer? All right, next bummer. So there's the rare earth hypothesis. So this was articulated by Peter Ward in his 2000 book Rare Earth. If you want to jam this into the Great Filter model, this is like an early filter. But basically, the idea is just that Earth, like planets, are rare in the universe. There are a few things that make Earth seem exceptionally special. We orbit a stable, long-lived single star in its habitable zone, and as you might know, most of the G-class stars, or most stars like our sun in our own galaxy, are not single stars. They have multi-star systems. If you've ever read or seen the Three Body Problem show, very much that is about the problem of how do you live in a solar system with multiple stars when they could have interactions that could pull your planet out of orbit, or could send you careening into one of the stars. Our orbit around the galaxy is in what is sort of controversially understood as the galactic habitable zone. So we're like about halfway, roughly, maybe a little bit more than halfway, I think, between the core of the Milky Way galaxy and the rim. And the basically the idea of this galactic habitable zone is this suggestion that, well, if we were much closer to the edge of the galaxy, it would be quieter. There would be fewer like neighboring stars that would interact with ours, but there would also be fewer metals. There would be fewer heavy elements, and we need those to make up our bodies, to make, like, iron in your blood, carbon in your bones, and all the other cool things that we do with elements. Nearer to the galactic core, obviously the stars are closer together. They have more interstellar interactions, and then you're more likely to run into those problems where a star comes through and sends a planet careening out of orbit. This is sort of a frontier in astronomy at this point, so that's why I mark it as controversial. We have plate tectonics on our planet. They process like the carbon in our atmosphere. We have an unusually large moon. In fact, it is a moon that is so large that some might call us a double planet. If you like Isaac Asimov, he will not let you forget that he thinks that Earth should be considered a double planet. You read a few of his books, he always has a character bring this up. So what's going on with that, with our huge moon, right? Like Mercury has no moons, Venus has no moons, Mars has two little teeny tiny potato ball moons, and those are all the other terrestrial planets in our solar system, unless you count Pluto. This talk's not about that. Now this book came out in 2000. Exoplanet astronomy has really gone crazy in the years since then. And what's really interesting, actually, is that it has basically confirmed that our solar system is unique, and other solar systems are generally not like ours. Specifically, prior to the dawn of exoplanet astronomy, generally when you ask astronomers what they thought solar systems looked like, they would say that they expect to see a region near the sun of terrestrial planets like Earth and Mars and Venus, and then an asteroid belt, and then a region of giant planets like Jupiter, Saturn, Uranus, Neptune. It turns out that what we found in looking at exoplanets is it's actually kind of either all one or all the other. And we don't really know whether other solar systems have asteroid belts because we don't have the technology to detect them at this point. Now, one issue I will point out with this hypothesis is that it makes the assumption that the only option for civilization is an Earth-like planet. But we know that there are other places where life could potentially exist. Like you could have like an ice ball moon like Europa or Enceladus that has a solid surface of ice with a liquid water ocean underneath. And I don't know, could there be life there? Yes. Could there be civilization? I'm going to move on to the next one. Okay, so now another hypothesis that suggests that we are alone is that we're early. So one of the assumptions, the Fermi paradox statement, is that civilizations are equally likely to appear at any time in the history of the universe. We know this is likely wrong because our civilization relies on heavy elements that didn't exist at the dawn of the universe, right? So when the Big Bang happened, the entire universe was made up of helium and hydrogen. And we can't build a civilization on helium and hydrogen. And we can't even build ourselves on helium and hydrogen. So Mario Livio is an astronomer who believes that there is no civilization that is more than 3 billion years ahead of us, and he based that calculation on the stellar production of carbon. By the way, if you assume that stellar carbon production is what dictates life in the universe, then we are early because stellar carbon production has not yet peaked. So yeah, carbon is required for life as we know it, is produced in stellar novae like this one. This is the Dumbbell Nebula, and I took this picture myself and posted it on my Instagram. Follow me at the Intergalactic Wanderer. Anyway, so it might be possible that we are early because later in the history of the universe, the entire galaxy is fully colonized. So you remember Robin Hansen? He's the guy who had the Great Filter hypothesis. He has a more recent paper he came out with where he suggested this model called grabby aliens, where he basically is making the argument. I could do a whole talk on grabby aliens. It's kind of like it's a little bit out of scope to get too deep into it, but basically the conclusion he draws in this paper is that we have to be early because all the other, like, if we're any later, then life can't appear, right? Like, if you imagine that Dune universe where every planet has a bunch of Sardaukar running around, and like life's not going to appear on an already inhabited world. We've seen that through our own history. We have seen no evidence that there was ever a second Genesis, as they call it, like a second appearance of life on Earth. Okay, so now the next one, civilization is rare. So perhaps life is common, but intelligent life and industrial civilization are not, right? So alien oceans appear to be common, but aquatic life likely never invents fire. This is the plot of the movie 2010, The Year We Make Contact. So it seems when we look around on Earth that many species appear to be roughly as intelligent as we are. You know, other apes, dolphins, whales, but they don't have complex language and tool making like our own. And as many as 20 other hominid species existed before us on Earth, including about like 4 to 6 that we coexisted with and also made babies with, like Neanderthals. It was only there were only two. There's only two other species that we interbred with. One of them was Neanderthals. Like I think it's like 5% of our DNA is Neanderthal DNA. And yet only we invented civilization. We're the only ones who came up with, you know, taxes and Netflix and high-speed internet. And as I noted in the Great Filter section, industrial civilization actually poses a lot of dire threats to our species, right? Dinosaurs ruled the Earth for millions of years, and they never invented any of that stuff. All right, we're all here to talk about aliens. We're probably bored of thinking about there not being aliens. So, what if there are aliens? All right, so our first solution where there are aliens, which is often a favorite, is that we just don't know how or where to look. So, around the turn of the 20th century, Percival Lowell, who is was a really great astronomer. He was an incredible man, and he built this beautiful observatory in Arizona, which you can still go and visit today. He was convinced that there was a civilization on Mars and that they were building canals to transport water from the polar ice caps to their equatorial cities. Now, I will note that at the time he made this observation, canal building was the latest technology. That was like the Erie Canal was being built, the Suez Canal, the Panama Canal, and also, so we've actually tried to figure out, you know, what what was it that he was drawing? Because he did this night after night. He would go out to his telescope, he would look at Mars, and he would draw these maps, and they were consistent. And you might be thinking, like, is he playing connect the dots here? Like, because it looks, you kind of see like some similarities between the photograph of Mars and what he drew, but we don't see any of the lines, right? So as far as we know, because like when we first sent spacecraft to Mars, Carl Sagan and Frank Drake actually took the data from their photographs and tried to match it up with the maps that were drawn by Percival Lowell, and they found no correlation. So what they concluded is that what Percival was doing was he was drawing the veins in his eye that were backlit by the planet. really, it's kind of depressing. But yeah, so we've been searching for extraterrestrial life for a very short period of time. It's possible that some of our assumptions about extraterrestrial civilizations might be biased, as they were in this case with looking for canals. If we did this today, we'd be looking for Wi-Fi. And even if there were extraterrestrial civilizations signaling to us on the radio spectrum, how would we know what frequency to listen to? So, a lot of people probably think that astronomers spend a lot of time and money and resources on searching for extraterrestrial intelligence, but it's actually one of the hardest types of astronomy projects to get funding for. And up until relatively recently, it was basically illegal to do in the United States. Like, Congress had a, a a restriction on NASA that prevented them from doing specifically looking for extraterrestrial intelligence. They were allowed to look for biosignatures, that is, signs of life, but they could not look for technosignatures, which would be signs of intelligent life. Only dumb aliens. So we even have a radio telescope here at Jenny Jump that was built for SETI research. It is sitting idle behind the house today. And actually, I mentioned the WOW signal. After that signal hit in 1977, the total observing time that was spent trying to reacquire the signal with the same telescope was only 100 hours. This is a chart from the SETI, or I think it's from Sky and Telescope magazine. I don't know if it's from the SETI Institute, but this chart shows basically the section of sky, like the fraction of the sky is on this axis, the frequency, and then the relative depth into space is on the z-axis. And I guess, well, if that's the z-axis, then it's not important. So basically what we're saying here is this is how much SETI we have done, how much we have covered of the possible places to look for extraterrestrial signals. Now, the note that we're talking about relative distance. The reason we're talking about relative distance is because you actually couldn't, the answering the question of how far away can we detect a signal from kind of depends on whether we're talking about an omnidirectional beacon, like a lighthouse that's just blasting into space in all directions, or the same amount of power in like a narrow band that's just slamming directly towards us, right? So there's you can only really talk about in relative terms, as it depends on the size of the emitter and the size of our receiver as well. But basically, as you can see, we actually have not spent a lot of time looking for or a lot of resources on searching. So our next solution is called the dark forest hypothesis. So this was originally articulated by a scientist and sci-fi writer named David Brin in 1983. Its spooky name, though, comes from the 2008 sci-fi novel The Dark Forest by Cixin Liu. I already mentioned his books before. This is from the series called The Three Body Problem. This is the second book in the series. So basically, this is the way it's articulated in the book, and I think this is actually the best way to explain it. So suppose a vast number of civilizations are distributed throughout the universe. Suppose that survival is the primary need of a civilization. Suppose that civilizations continuously expand over time, but the matter in the universe, and therefore the resources, remains constant. So basically the conclusion is that all civilizations will be hostile, or as I put it, stay strapped or get zapped. So if there were an interstellar war, you would want to win on the first shot. You would not want to have launch an invasion fleet that goes to the alien star system and lands, and you find out that, oh, you spent 500 years in deep space and we've had 500 years to build new and more powerful weapons. So you would probably want to use something that was more effective and basically one shots your enemy. So a few ideas that are really cool here is this idea of a relativistic impactor, which is this is an artist's conception of what that might look like. By the way, that's not a real photograph. We're okay. So this would be this basically what would happen if somebody launched a moon at us at, say, I guess, and the fact that there's a photo tells me that this is actually not quite relativistic, but we're talking about the idea of you're sending something at 99% the speed of light. So we have no early warning system for this, right? Because if it comes from 100 light years away, you're gonna see it launch 1 year before it hits. You could have some sort of particle beam weapon that would be of a similar like level of destructive scale. But the really cool one is the information warfare one. So I talked about the movie Contact, right? You remember that these aliens, they send us this message, and the message contains blueprints to build a machine, and it's a wormhole machine that they can use to talk to Jodie Foster for 5 minutes. But like, what if instead they sent us like the blueprints for a massive bomb that would destroy the planet, and we would have no way of knowing because we don't have their access to their level of technology. And so this is basically that's basically the dark forest hypothesis. Here's the problem with this solution. How would we hide? So like, even if we turned off all our communication systems, our weather our radar, our air traffic control radar, our missile defense radars, which I don't think we want to turn off, like, what we all the signals we've sent into space in the radio spectrum are already going. So like, we're not hiding in that sense. And also, Earth is very obviously covered in life. Even if we didn't have any techno-signatures that were going out into space, and radio waves are not the only type of techno-signature going to space. We have also signs of our pollution. You could probably detect the Earth in the sodium line because we use, or not sodium, or yeah, sodium. We use sodium in our street lamps. So like, the atomic line of sodium would be visible in light from Earth because it's in all of our street lamps. The biosignatures are really obvious. Our planet's covered in oxygen. Oxygen does not usually occur in the atmosphere of a planet without oxidizing out into something on the surface. So the fact that we have not been zapped yet is probably, hopefully, a sign that we're not in a dark forest, other than the dark forest that we're here in Jenny Jump. Okay, so now one more, stay-at-home civilization. So this is basically the idea that interstellar civilization just isn't a thing, and interstellar colonization might just be impossible. So this is what Kim Stanley Robinson articulates in his novel Aurora. Basically, the idea is that life is a planetary phenomenon, and therefore we encounter two types of planets: lifeless rocks and hostile environments. So colonialism in the history of Earth has historically focused on seizing resources. So that's why I have this map of the British Empire. This is actually the British Empire at its greatest extent at this time. I believe they controlled about 23% of the Earth's landmass and a similar percentage of the Earth's population. And what I am showing you here is their communication system. This is their telegraph lines. So you see they have these undersea telegraph cables that go from England to Canada, across the Pacific to Australia and New Zealand, across the Indian Ocean to Ceylon, Sri Lanka, and then across to South Africa, and then back to England. So if I'm the Prime Minister and you're the Viceroy of India, and I want to tell you what to do, I can tap out my orders and you'll get them at the speed of light, basically instantaneously. Now imagine I'm the Emperor of the galaxy and you're my Viceroy at Alpha Centauri. I gotta wait 4 years for my orders to transmit to you at the speed of light, and then I gotta wait another 4 more years to find out whether you decided to obey them or not. So it's possible now. Not only that, right? Those resources basically seem to be the same in almost every solar system, right? Like, how big would human civilization have to become before we've exhausted the asteroid belt, the outer planets, the Oort cloud? It might be that there's not really, like, and you see this in sci-fi movies a lot because they often have to come up with like a reason why the aliens come here to Earth, and it's like, oh, they want our water, or like they want the minerals on Earth. I'm like, dude, like, Pluto is basically made of water. You guys can take it. Like, actually, that would solve some problems for us if you just backed the truck up and hauled it back home with you. So it's possible that there might not be much reason to colonize other solar systems. And now, finally, for the one that I think I actually expected when I first wrote this talk, I expected this to be the most popular solution. That's the aliens are already here, right? So like, some people, maybe in the in-person audience, hopefully the online audience, are probably thinking, Dan, you're missing the forest for the trees here. We got UFOs are zipping around all over the place. We got that alien spaceship that crashed at Roswell. Like, with there's definitely aliens. And yeah, I think there's some problems with this idea. Modern astronomical surveys, both professional astronomers and amateur astronomers, basically image the entire night sky every clear night. So if there were extraordinary craft, if there were extraordinary craft routinely flying around in Earth's atmosphere, why are they not showing up in astronomical data? And generally, any astronomer will tell you lay people are not very skilled at identifying flying objects. We routinely get phone calls here at the observatory to confirm UFO sightings. And I'll tell you, usually they are things like Venus, Jupiter, the Pleiades, Starlink satellites, SpaceX launches. But now some of you might be thinking, well, what about the UFO files? So yeah, a bit of background on that. In 2017, the New York Times published some leaked U.S. Navy infrared videos showing what the military now calls or UAPs, which stands for unidentified anomalous phenomena or unidentified aerial phenomena. And I guess part of the rebranding is like, well, we don't necessarily know whether this is a flying since like a balloon does a balloon fly or does it float, right? And is it whether it's an object, right? If it's something that's just like shimmering, it might not actually be a physical object. So these videos do look strange, but it is surprisingly difficult to interpret imagery from classified infrared targeting cameras. Now I'm going to take a brief aside here to talk about like how I was somewhat radicalized against UFOs. So around this time, 2017, there was a podcast I was listening to, which I won't name, that covered this, and they played this clip from one of Mick West's YouTube videos where he offered his explanation of these videos, and it was like a split second, like blink and you missed it, clip of him. And then they spent like 30 or 40 minutes talking about Project Blue Book and MK Ultra and the X Files and all these other like UFO topics. And I was sitting here like, wait, get that guy back in here. It sounded like he figured it out. Like, and so if you look at this is the Tic Tac video. This was associated with the USS Nimitz incident. I don't have enough time to go into detail about the Nimitz incident, but if you look at Mick West's YouTube channel, he has a pretty convincing case that this looks like a regular airplane flying in a straight line at a steady speed, but just out of focus. And it actually is possible it could be a Chinese spy plane, but just a plane. And the analyses by scientists, image analysts, and the Department of Defense and NASA have basically lined up with the conclusions that Mick has had. He's not actually an expert. He's a video game programmer, but he was able to leverage his skills with video game programming to build simulations to try to recreate these videos. And then in 2026, the government released the UFO files, which appear to be more of the same videos that are consistent with ordinary aircraft, balloons, sensor artifacts, or camera effects. So I just want to make a few comments here about how I think is best to approach UFO stories. And I think that they're best formed as a series of questions. So, does the story rely on leaping to conclusions without considering mundane alternatives? Remember, we said it's not aliens until it's aliens. Does the story contain instant gratification? Okay, so I can tell you from experience, all right? I know this guy pretty well. It can take me a long time to find objects that are in the book, like in my charts, that my telescope's computer knows the location of. It can be difficult for me to find them. I saw this a lot during the drone panic in like December 2024, January 2025, where like people I would run into people who were walking outside, and within 5 seconds they were seeing these extraordinary aircraft that were like nothing they'd ever seen before. I'm telling you, man, if you go outside and the first thing you see is aliens, it's probably not aliens. Does the story rely on authority instead of evidence? This is a very common pattern in UFO stories. You'll often see someone described as, oh, they're a fighter pilot with 20 years of experience, and they've been down this road a million times, and they're a serious person, a police officer, not a UFO kook or something. But experts make mistakes every day. That's why planes crash. Does the person telling the story have something to gain? You would be surprised how many UFO storytellers have books to sell, documentaries to sell, podcasts, television appearances, conference tickets, and YouTube channels. And finally, are the details surprisingly sloppy or mismatched to the available evidence? So talking about these Navy UFO videos, right? It's very strange that you'll see people say there are no visible signs of propulsion, when showing an infrared video. Fighter planes have infrared cameras because infrared readily shows signs of propulsion. That is the jet wash of the engines. So this is the gimbal video. This is one of the 3 that got leaked in 2017, and it seems likely that this is a video of an infrared glare. That I'm not saying it's not an alien spaceship, but what I am saying is that the reason you see this object appear to rotate is actually because the camera is rotating, and what you're seeing rotate is the glare produced by the infrared light within the camera's lens. You can actually replicate this event. You can replicate this effect using a flashlight and 2 smartphones. But yeah, okay. So, all right. So you're thinking to yourself, so Dan, you don't think there's anything to this UFO stuff? And, all right, look, man, I'm a 90s kid. I love my X-Files. I want to believe, but we have spent a lot of time and money looking into UFOs, and so far we have not found anything nearly as exciting or tantalizing as the WOW signal. Now, as I think you've probably seen, I do my best in this talk to provide the best case for each and every one of these solutions, but the paucity of evidence around UFOs makes it difficult for me to take this one very seriously. Now, don't let my cynicism spoil it for you. If you think they're already here, vote for they're already here. All right, so now we're going to do our bracket. I think I have to reset it. Yeah. Oh no. You can see the previous winner. How do I start it again?
Yeah, I'd probably need my glasses to see that though.
Oh, that's good. Wait a minute. Oh, I think I have to log in. Yeah. Hey.
I was about to say that might not be something you want. So, online people, he is currently just slightly unplugged his computer, so you guys don't have to see his password information as you should want. Technology and information security. There's a whole field.
I should have logged this in before we started. That's on me. Okay. So yes, to reset bracket and okay, we're gonna start. So coming back. I'm sorry about that. That's totally on me. I should do better than this. Okay, so we're gonna go by applausometer.
And online people, you're going to type the number. So
stay-at-home civilizations or great filter.
1.
So stay-at-home civilizations is number 1. It's the solution where nobody ever leaves their home solar system, and great filter is the one where we all die.
And that number is 8?
It's 8.
Okay. I don't have my distance glasses on, so
I can see. All right. Stay-at-home civilizations. We go with a woo or hands up. Okay, I think we have 2 votes for stay-at-home. Great filter. Kind of. That's all right. Great filter wins.
There were more hands.
Okay. We are early versus we don't know how or where to look. So we are early is number 5. We don't know how or where to look is number 4. So we are early. This is the idea that there are other civilizations, but we're the first one, and we're going to take over the galaxy. It's going to be like in Dune. We are early. We don't know how or where to look. It's a very powerful solution. Okay, they're already here versus rare civilization. So they're already here is number 3. Rare civilization is number 6. So they're already here. There's aliens among us. Who knows? Maybe I'm an alien. They're already here.
I don't know. Sometimes the way.
Rare civilization is rare. I think that was they're already here.
We have like
one
half of the 10 going against the other half.
I feel like there's a bit of a tribal mismatch here. Anything from online to be the tiebreaker?
Honestly, they've been a little quiet.
Okay. I'm going to go with they're already here. Dark Forest versus Rare Earth. So Dark Forest is number 7, Rare Earth is number 2. Dark Forest is spooky, everybody's out to get us. Rare Earth is actually there's nobody out there to get anything because we're the only ones who are alive. So, Dark Forest hypothesis,
One,
Rare
two,
Earth
three, 4, 5.
hypothesis.
That was Dark
Clear
Forest.
by a country mile. All right, next round. So Great Filter versus We Don't Know How or Where to Look. Great Filter is number 8. We Don't Know How or Where to Look is number 4. So Great Filter. We don't know how or where to look.
Like every hand.
Like
went
every
up.
hand went up. That was unambiguous. They're already here versus Dark. That's amazing because they could be already here and the Dark Forest. They could be here to kill us. All right, so they're already here. Dark Forest. I gotta say, between the two, I think I actually find Dark Forest more credible. I shouldn't be saying that. Okay, We Don't Know How or Where to Look versus Dark Forest. We don't know how or where to look.
4,
Dark Forest.
which is 7.
Okay, so you have the honor of being. I don't know how many times I've run this talk at this point,
You
but
should
this.
probably start a spreadsheet that tracks the stats.
So the stat that I already know is that We Don't Know How or Where to Look has won every single time. But I don't know how good the others have done, and they have been like.
I feel like you should track these stats.
Yeah. So okay. So before we close out, I have some additional further reading if you're interested. I'm going to tell you a fun little story. So a few really good books on this topic. If the universe is teeming with aliens, where is everybody? Second edition, 75 Solutions to the Fermi Paradox and the Problem of Extraterrestrial Life by Stephen Webb. Aliens, the World of the Leading Scientists on the Search for Extraterrestrial Life by Jim Al-Khalili. And a really interesting book, I really like this one, it's called UFO, The Inside Story of the U.S. Government's Search for Alien Life Here and Out There by Garrett M. Graff. So this one is really interesting because it kind of does a parallel history of both the astronomy SETI, which we would consider serious science, and the UFO subculture, as well as U.S. government surveys of UFOs, Air Force surveys of UFOs. And finally, the really fun one, Why We Might Be Alone, is a lecture by Professor David Kipping. All these are linked in a link tree I built that if you follow this QR code, you'll find. So this is where I get to tell you this fun story. So this is actually how I thought of this talk, or how I came up with the idea for this talk. So I went to this lecture. This was at Columbia University. David Kipping's really cool. He does a bunch of really great research in astronomy. He also does a YouTube channel. He's also very good looking, and I know that because there were college girls there were college students who were sitting next to me who were taking creep shots of him because he's such a good looking guy. But anyway, so in this at the end of the talk, right? I raised my hand to ask a question. I asked him, what does he think of the grabby aliens model? And I actually said, I don't want to start beef between astronomers, but like, what do you think of Robin Hansen's grabby aliens model? And he said, well, the model's valid, but you can buy books that are like 101 solutions to the Fermi paradox. So of course I went home and I went on Amazon and I typed in 101 solutions to the Fermi paradox, and I found Stephen Webb's book, which actually only had 75. And then I read it and I was like, this is such an interesting like topic of conversation. Like I would meet people and I'd say, what do you think is the solution to the Fermi paradox? It's like an icebreaker question. And then I kind of had the idea of like, but why don't I just do a talk
That
about
is a
exactly
very
that?
small subset of the population who could probably ask that question.
But a subset that I spend a lot of time really late at night with. But anyway, so I will leave you with this quote from Arthur C. Clarke, who's one of my favorite science fiction writers. Two possibilities exist. Either we are alone in the universe or we are not. Both are equally terrifying.
All right. Thank you, Dan, for another great talk. So, we will be doing a question and answer session. And how that's going to work is the people here, you're going to raise your hand and wave it about. Because as you've noticed, I don't have my distance glasses. And when it gets dark, you all become the shapes in the dark. And this is the dark, scary forest. So, unfortunately, if you put your hand down and cease to move, I'm much like the T-Rex in Jurassic Park, and you no longer exist. You just become one of one with the shadowy figures in the dark. Online people have it easy. You guys just get to type the questions, and then I get to read them. And with that, I'm going to start off with this first comment from our online
A
audience.
comment. Okay.
He yelled at Kim for doxing him and then gives away his license plate number. Facepalm.
I actually, that license plate. So I got the idea for that from Stellafane, because at Stellafane I noticed a lot of people had really cool like astronomy themed vanity plates. I think there was one that said Cygnus. There was one that said I gaze, which was really good. And there was somebody who was next to me at Cherry Spring Star Party this year, and I think his plate was like I forgot Ada Karina. It was like ETA CRN or something like that. And I just thought like, oh, this is such a cool license plate, because if you Google it, like it looks like a normal license plate. It's a series of letters and numbers, but if you Google it, it immediately pops up the wow signal. So it's like, oh, only really cool people will figure this out.
All right. Anyone out here? All right. Just keep in mind, if you have a question, feel free to raise your hand. On to our first actual online question. Didn't one place have to throw away some of its data because they realized some of the signals they were seeing were caused by the microwave heating stuff up in the break
I
room?
remember this. Yeah, I remember this story. So I'm working on another talk on this topic, which I'm going to be doing on July 25th, unless somebody else took that time slot. And the title of that talk is going to be all the times we didn't find aliens. And it's basically going to be about the history of like things like that, where like sometimes it's really frustrating, like, oh, it was a microwave, but like also a lot of really cool astronomy has been done by looking for aliens and not finding them. Like pulsars, when we first discovered them, we thought they were possibly alien signals. Now we know actually they are rapidly rotating neutron stars that are basically like they basically act like lighthouses.
But yeah, this is why, and actually part of how science progresses. You go, oh yes, this is interesting, and then you realize there was a
Mm.
problem, and there's also why there's this whole subset of science and engineering of isolating data from other variables possible and noise reduction. Um,
I have a story about this too. This happened to me too. So there was I was out here one night, and if you do astrophotography, it's very common to see satellites pass through the frame, and usually they zip by in like one sub frame. Like if you're doing 5 minute subs, even 30-second subs, it goes right through. And I had the satellite that was in my frame for like, I don't know, it's like half an hour. It was really like every sub it had this satellite. I was shooting the Crab Nebula, and I was really confused. I was like, how does the satellite have this much hang time? And when I got home, I like did some back of the envelope math to try to impute its orbit, like based on, okay, well, so if like this is the size of, like, this is roughly the angular size of what the frame should be. So this is how long its period would be if it was a circular orbit. How high up is it, right? And I made some sort of arithmetic error, and I wound up with it being like 2/3 of the way to the moon. And there's very few satellites that are that high up, because there's really not much to do up there. Like they would have to be a science package to be that far away from Earth. And I was like, oh my God, did I find an undocumented satellite? Have I discovered like a spy satellite that nobody knows about? And then I just decided to go on Heavens Above and look at the like satellite track for that time of day. It turned out the reason it had that hang time is because it was a Navstar GPS satellite, and I just made a mistake in my math and wound up with an orbit that was not realistic.
aren't the GPS and nav ones usually geostationary?
Yes, exactly. And but I got a
Okay.
number that Geo is in, like,
Haha,
I think Geo's
learning.
like 60,000 kilometers. I got a number that was way more than that. But yeah, and yes, like the GPS satellites have a ton of hang time because they're basically function like stars, right? Like the way a sextant works is you're like aligning with a star that's basically an infinity. GPS satellites are designed to do the same thing as that. That's why they're so high up.
All right. Questions? All right. They're being very kind to you and not heckling you at
I know,
all.
right? This is because Jeff's upstairs.
Actually, I think Jeff left.
Really?
I think he ran away from you. All right. So our next thing is, wouldn't aquatic life not need to invent radio because regular sound travels very well in water and radio doesn't necessarily penetrate well in water?
I mean, did we invent radio because we wanted to use it as a substitute for sound? Like, I mean, I guess I think that like the discourse around aquatic life is usually this idea, and you see this in a lot of science fiction, is this idea that like in order for civilization to appear, we needed to invent fire, and fire doesn't work underwater. I think it's kind of interesting because it's one of those ideas that's like it makes sense in science fiction, but I have read sci-fi novels where they come up with ways for aquatic life forms to come up with interstellar travel. But yeah, I mean, I guess they probably wouldn't have radio.
I also don't know that fire doesn't work underwater is always necessarily true because otherwise
Hmm.
they wouldn't have the people who go down and weld.
I mean, I'm sure there's a bunch of stuff you have to do for undersea welding to work.
I don't know. Also, fun facts. So one of our member clubs, East Brunswick Astronomy Club, had a presentation recently, and the presenter was going, did what it was about her time on an ocean research vessel where they were studying uh deep sea like geothermal stuff and whatnot, and specifically on the Atlantic Massif in like that Lost City White Smoker area.
Hmm.
And they're using that data to help inform uh how they might search for life on places like Europa. Europa's the icy one,
Yep, I
right?
mentioned it before. That's a good example of an ice ball moon.
Uh because life does in fact live in and around the very extreme area where humans definitely could not survive that. So they're hoping to use that sort of information to inform searching for stuff like that elsewhere. So, uh, let's see. Any? So our next question is, uh, where'd it go? Can a person purposefully see the blood vessels in their eyes like they speculate Lowell did?
Probably. I think you just have to go to an optometrist for that. I feel like every time I go to the optometrist, they have a bunch of tests I have to do that shine some light in my eyes, and it takes me like a billion tries. But every time I see the blood vessels,
All right, and one of our online viewers actually someone answered this, and I am going to butcher this name. Uh, P- I'll spell it first. Purkinje. So the Purkinje tree trick.
I have no idea what that is.
Where the theory is, if you're at your big telescope and staring at Mars while it wobbles around due to seeing, you can create a situation where your brain starts to ignore the shadows cast by the blood vessels and you can actually see them.
Them being the canals or the blood vessels?
I believe the blood vessels.
But well, I guess we're concluding those are the same thing.
I think that was trying to answer that online
Yeah.
question. So apparently there's ways where you can see your own eyeball blood vessels, which is neat. Uh, I don't know that I actually want to do that though, because that also sounds like potential eye damage. All right. So online people, if you have any last minute questions, do get those in. I like to give you guys a couple extra minutes because by the time they hear that, we're off into the future because that's how stream delay works. Apparently, I need to do some modding in chat. We got a bot, so that's not great.
Somebody's giving away a MacBook in there or something. Like,
No, and we're not even gonna go there.
all right.
Anyhow, I do want to thank everyone, like I said, who has joined us here in the state forest, and another thanks to you, Dan, for giving a great talk, and for everyone joining us online. Just a reminder, our website uacnj.org. It's a great resource to find a whole bunch of information, like our upcoming talks, our past talks, links to so many things like our social media, our or our
YouTube,
member clubs.
our we're on Patreon, which is one that's a very that's a great one you should go to. And our gift shop also there. That's another place where you can give us money. We are on Instagram. I'm on Instagram. And we have Discord. Again, you can get on our Discord and ask us questions about how to use the very expensive telescope you just bought. We're always here in Jenny Jump State Forest.
Also, I do want to thank everyone who has spent time and also donated. We have been doing a fundraiser uh, for building a new observatory here on site to house the 25-inch telescope donated by Alan Medkiff. Uh, so good job. Thank you so much for those donations. We do appreciate it. These programs are always free. So in the light of giving you ways to support us for free, do hit those like, subscribe, follow buttons, the free actions. But we never expect donations, but they are always appreciated to help us fund projects like I said, that new telescope housing, or just general upkeep which allows us to offer these outreach opportunities. So, since it looks like the online questions have passed, uh,
Nothing for you guys.
sorry,
All right.
I had to hiccup there. I'm like, let's not do that directly into the mic. All right, I do want to thank you all once again, and with that, clearer skies than the solid layer of clouds we have currently, and good seeing.
Live
Until
long and
next
prosper.
time.
May the force be with you. Oh, that wasn't the power button.